Hello everyone! For this given circle T, we are asked to solve for the values of the variables x, y, and z in their respective placement. We need to identify first what are these variables referring to and look into their relationship as a whole together with the given measurements in order for us to derive correct and appropriate equations that will solve their measurements. X here is what we call as an inscribed angle. For a definition that its vertex is a point on the circle and its sides are considered to be chords of circle T. This is also true with angle Y. Angle Y is also considered to be an inscribed angle, for its vertex is a point on the circle and its sides are chords. For angle X, being the inscribed angle, its intercepted arc is this arc here, which measures 80 degrees. But as for angle Y, its intercepted arc is this arc here that is represented by a variable z. In order for us to solve the unknown measurements of these three variables, we need to understand the definition for the measurement of inscribed angles in its relation to its intercepted arc. The measurement of an inscribed angle is equal to half the measurement of its intercepted arc. So if we look closely at x, its measurement is just equal to 1/2 the measurement of its intercepted arc, which is in this case this arc here, and it's given to be 80 degrees. So again, the measurement of the inscribed angle x is just 1/2 of the measurement of its intercepted arc, which is given to be 80 degrees. With this equation, we can show that the measurement of angle x is just equal to half of 80 degrees, which is 40 degrees. This is the measurement of angle x. For angle y, using the same pattern, we just need to get the half or divide the measurement of its intercepted arc by 2. But the intercepted arc of angle y, being the inscribed angle, is also unknown, for it is actually denoted as another variable z. So we cannot use the same concept here in solving for y. But what we could do is to look into the given figure that it has formed inside the circle T. We already have this angle here, and this angle here is already given as 66 degrees. The figure inside the circle is what we call as a triangle, and we already know per triangle angle sum theorem that the sum of the interior angles of any triangle is equal to 180 degrees. That would mean if we're going to sum up the measurement of angle x plus the given value of 66 degrees for this inscribed angle plus the measurement of angle y, the sum must reach exactly 180 degrees. As of this equation is concerned, we have two variables here, but we already solved the value of the measurement of angle x earlier. So we just simply plug in that value here, 40 degrees plus 66 degrees plus the measurement of angle y, which is equivalent to 180 degrees. This would mean that the measurement of angle y can be solved when we subtract from 180 degrees the sum of 40 and 66, being 106 degrees. When we do that, we could get the value of the measurement of angle y, which also represents our unknown y here. In short, the measurement of angle y is just equal to 180 degrees minus 106 degrees. That's actually equal to 74 degrees. So we are now done with angle y using the value that we had earlier for angle x. In solving the measurement of z, we need to look into the consideration that whatever would be the value of the measurement of angle y, it is just half of z. In short, to get the measurement of angle y, it is just half of z. But since it's z that we are looking for, not y, for it is already given, what we could do for this equation is to multiply both sides by 2 to get an equation intended for z. And that's actually z is equal to twice, as we multiply 2 on both sides, this would cancel out, twice the measurement of angle y. Moving forward, z, or arc z in this manner, is just twice the measurement of angle y, which is 74 degrees, which will give you a result for z that is equal to 148 degrees. This is the measurement for z, which is the intercepted arc of angle y. Now, there is also one way for us to check whether our answer is correct or not. This is 148 degrees pertaining to our solution. We also have 80 degrees. This would mean that whatever the value of this remaining minor arc, it should complete the total circumference of 360 degrees. To do that, we have here 66 degrees as the inscribed angle of this and its intercepted arc is the arc that what we are looking for to complete the 360 degrees. And since there is an inscribed angle, in short, it's just half of this. We need to multiply 66 by 2 to get a value of 132 degrees. And if we add all of those three arcs here, 148 plus 132 is 280 degrees. Plus the given 80 degrees, it rolls out to the entire circumference of 360 degrees. This is just one way for you to know whether your answer is correct or not. This is how we solve the unknown measurements for this given circle T.